Hello, welcome back to Math 152. We're going to go into some Chapter 3 stuff today. Let's get started. So our first topic is going to be measure for Section 3.1 is measures of center. We're going to see that we're going to have several means that we can kind of measure the center with different techniques and provide different numbers so that we can get an idea of where the center of data is. And we'll talk about that. So our objectives today: compute the mean of a data set, compute the median of a data set, compare the properties of the mean and the median, find the mode of a data set, and approximate the mean with group data. Excuse me. So objective one, compute the mean of a data set. We've been doing this, I'm sure, since we were in grade school, of calculating the average of a set of numbers. And the mean is just a different way, as a statistical way of saying the average. So let me pull this mean drop down here. The mean of a data set is a measure of center. So if I've got several data variables, points, and I want to know the average of them, we talk about in statistics the mean. So the mean of a data set is a measure of center, where the center of the data is. The mean of a data set is a measure of center. If we imagine each data value to be a weight, then the mean is at the point at which the data set balances. So here we have some numbers: 68, 78, 83, 85, and 92. These are the values of our data set. And if we add up all of these numbers and divide it by the number that we've got, 1, 2, 3, 4, 5, we end up with the mean. That's the 81.2. And if we imagine this as being a scale and these are weights pulling down this side, pulling down on this side, this thing would balance out at that point. If these were on like a distances, here would be the point where you would be able to balance. So replace everything with this one value and you would be the same. So we need to talk about some notation. I've talked about this before. Whether we're talking about a population data or sample data. So population data, you remember, that's all the data of a concern. So if I wanted to do a study about the mean age of everybody in Johnston County, the population data would be all the people in Johnston County, would include anything else. The sample would be if I find it inconvenient to go and ask everybody in Johnston County their age, I would look to get a sample and then use that sample as a representative measure of the population mean. Okay. So recall the population consists of an entire collection of individuals about which information is sought. I would like this number. This may be inconvenient, so I'm going to go after a sample data. And a sample consists of a smaller group drawn from the population. The method for calculating the mean is the same for both samples and population, except for the notation. When we're talking about the population mean, we're going to use this Greek symbol mu, and that's going to represent it. When I write down mu, we're talking about the population mean. If I only have a sample, I will need to use this X bar. That's the sample mean. That says that we had to go and get a sample. We don't know all the data in the population, but we took a sample, we measured that, and we basically came up with the average or the mean of the sample. So that's the X bar. So in order to compute the mean, we're going to compute the mean whether it's population or sample data the very same way. But we're going to notate it differently. So if we have a set of numbers, x1, x2, xn, and I'm going to let this little big E, it looks like a big E, that's the big sigma, and it says basically in mathematics, I want to sum up these values. This little I is a subscript, it just says a different value, and usually there's a little notation here. The summation means take all the values over those i's. So this, the sum of the x of I, means to add up x1, x2, x3, all the way up to ... means to continue on, all the way up to x sub n, as it's called, and we'll just add up all those data, but that we then have to divide by the number in the data set. So the sample mean is given by x bar, would be the sum of these data points divided by n. I'm using this x bar because I don't have all the data. It is just from a sampling of the population. But here, the very same formula, I'm using a big N here that says this is the big N of all the population data. This was the number of data points. And here is the population mean. So the calculation is the same thing. It would come up with the very same number. If I had these same numbers represent a sample, the same number represents the population, but it is two different things indeed. So let's see how we can compute the mean. During a semester, a student took 5 exams. The population of exam scores is 78, 83, 92, 68, and 85. And the question says find the mean. So we're going to basically add up these numbers, 78, 83, 92, 68, and 85. Hit that on our calculator, divide it by 1, 2, 3, 4, 5. That'll give us the value. A student took 5 exams. The population of exam scores. The population says all I'm concerned about is that student. So that's that population data. I'm going to use mu to represent that mean. So let's see how we do it. Here's the solution. The mean is given by mu because we're talking about the population of exam scores only of that student. It's the only ones I'm concerned with. I'm going to sum up all of his scores, add them up. This is going to be 406 up here. I'm going to divide by 5. That'll give me the 81.2. So mu, the mean, population mean is 81.2. So let me pull this up here so we can finish up. Note that the mean is rounded to one more decimal place than the original data. This is generally considered good practice. We'll try to stick with that. So these were 2 whole numbers. We'll go to the 10th. Back down here. So our objective 2 is compute the median of a data set. So we'll have to see what a median is. So the median is another measure of center. The median is a number that splits the data sets in half so that half the data values are less than the median, half the data values are greater than the median. So there's procedure for computing the median, and it depends on whether we have an odd number in our data set or a even number of items in our data set. So if n is odd, 3, 5, 7, 9, 11, we're going to go to the middle. So if we divided that number, let's say if we had 13 data items. Well, let's just use this one. 1, 2, 3, 4, 5, 6, 7. If I divide 7 by 2, I would get what? 3.5, right? That 0.5 says this was odd. If I had 6 divided by 2, I would get 3. That would be an even number. That said that 6 was an even number because it was divisible by 2. So the 3.5, I'm going to go 3 less, 3 more, and that one in the middle, that odd one in the middle, is what I'm going to call the median. So we have to order the data first, and now this number is going to tell us half the numbers are less than that, half the numbers are greater than that. Okay. If we come up, let me put me up here, sorry. If n is even, so here we've got 1, 2, 3, 4, 5, 6, 7, 8. If I divide 8 by 2, I get 4. That's what happens if I divide an even number by 2. I get a whole number. I'm going to go in and find the middle 2 numbers. So if I divide the 8 by the 2, I get 4. So I'm going to go 1, 2, 3, 4, and the 5th one. So I've got 3 above, 3 below, or 3 below, 3 above. Right here, I'm going to take the average of these 2 numbers, and the median is going to be that number that's kind of in the middle of those. So I'm going to use this number to split those 2. Okay. During a semester, a student took 5 exams. The population of exam scores is 78, 83, 92, 68, and 85. Find the median of the exam scores. So in this case, they're not ordered, so the very first thing I'm going to do before we do anything else is go ahead and order the data. So here it is, arrange the data values in increasing order. 68, 78, 83, 85, 92, they're ordered up. I've got 1, 2, 3, 4, 5. That's an odd number. So for an odd number to find the median, once it's ordered, is just go to that middle odd person out, 2 above, 2 below, 2 above. There's our 83. So the median is the middle number, 83. So here, 8 patients undergo a new surgical procedure, and the number of days spent in recovery for each is as follows. Find the median number of days in recovery. So here, again, it's not ordered, so our first thing we're going to have to do is order them. We're going to have to count 1, 2, 3, 4, 5, 6, 7, 8. 8's an even number, so we're going to have to order them up, look at those two middle numbers, and do an average of those. Let me move up here. Here's our data values arranged in increasing order. I want to go, I had 8. 8 divided by 2 is 4, so 1, 2, 3, 4. And then the next one up, I'm going to average those two data points. 15 plus 19 divided by 2, that's going to be 17. That's our median for this data set. So if you have an 84 plus, our textbook provides a lot of instructions for 84 plus. If you have 84 plus, the one var stats command and the TI-84, we'll go over this more in class. You can basically go through. The calculator displays a list of the most common parameters and statistics for a given data set. We'll just do the one var statistics. We'll put it in our L1, do this little calculation. And here's the output, and we just wanted to kind of give you the ideas of what these things are. So here, you will always be listed as X bar the mean. You will have to determine if your data was population data or sample data. If it was sample, you will use X bar, and if it's population, you will convert this. You just change this when you're writing this in your report. You would, or in a problem, you would use the mu for that. Sample standard deviation, the population standard deviation, we're going to talk about this in a few minutes. Here's the median that we've just finished up with. So it'll give us these others, and we'll go through and talk about the rest of them as we come to them. So here's the solution. They enter the data in list L1. Stat, highlight the calc menu, run the one var stats command with L1 as the list option. Back up here. And here's the value. So here would be, all I'm looking for is the median in this case. There's the median is 83. So one comment on the median, depending on your data set and what you're doing, like in Excel, it may not be as simple. They may have a better value for the median than our simple. Just take the middle two or the odd one out. Odd one out usually is pretty clean. The two middle ones, they may weight a little differently to give a better value of the median. So sometimes this may be a little different than what you would if you calculate it by hand, but I'm aware. I understand that that's going to happen when you report your data. Compare the properties of the mean and the median. This is, at times, you're going to get, now certainly these two things are going to be different in general. They can be the same, but we're going to look at it, and comparing those two numbers, we can ascertain what the shape of the data looks like. You remember that left skewed, right skewed, symmetric. We'll be able to use these numbers to determine that. So let me pull it down here so we can go over these slides. So a statistic is called resistant if its value is not affected much by extreme values, large or small, of the data set. The median is resistant, but the mean is not. So I would use the median. The median is a better measure of center if we have something like payroll. If we're considering like NBA players or professional football players, they may have a big range in their salary scales. If we did the average, those two players that may be the top of the game in their salaries, if we use theirs and doing the mean, that mean is really not resistant to that. So it's going to skew it way up there. if we reported those values, here is the average pay that our players get. There's probably more players that are going to be less than that average, and then they're going to go complain. Same thing with housing. If you consider there may be 2 or 3 houses in the area that may be the $1 million house, that's going to really pull the mean up, and it's not going to be representative of the typical house. The median is going to be more representative of the typical house. Okay. So if you change one of the data points, like the most extreme, you could change that to a much higher value, and the median is not going to change. The median point is still saying half less, half more. So 5 families have annual incomes of $25,000, $31,000, $34,000, $44,000, and $56,000. One family whose income is $25,000 wins a $1 million lottery, so their income increases to $1,025,000. So here's the values of these two. If we calculate these out, the mean before the lottery win was $38,000, and the mean was $34,000. We changed this lowest income. Now he's the highest, so we really switched all of these around. And in this case, the mean goes up to $238,000. Didn't matter which way we added these up, they're always going to come up with that the mean $238,000. The median in this case, look, it only went up by $10,000, even though the lowest person all of a sudden got bumped up to the highest and everything went down. So this was the lowest now. The median only went up to $44,000. So it is more representative of most of the family incomes from that case. Okay. So I'm going to go up here so I can finish up this. The extreme value of $1,025,000 influences the mean quite a lot. Look, from $38,000 to $238,000. In comparison, the median has been influenced much less, increasing from $34,000 to $44,000. So the median is much less resistant, or much more resistant to those than what the mean is. Here's also some comparisons. Let me get these two down up here first. The mean and median measure the center of a data set in different ways. When a data set is symmetric, the mean and median are equal. So if I give you two numbers, 34,000 and 34,000, the mean is 34,000, the median is 34,000, you can say that data is symmetric around there. Okay? If these two values are the same, you are dealing with symmetric data. When a data set is skewed to the right, there are large values in the right tail. This is where that lottery is all pulled up. And remember that mean got pulled up with those high lottery wins. The median stayed down. So anytime you're given two numbers, the median and the mean, if it is right skewed, the mean is greater than the median. And if the mean is greater than the median, that means that it's right skewed. Go up here. Similarly, when a data set is skewed to the left, the mean is often less than the median. So if you're given two with different numbers, if the mean is less than the median, that is skewed to the left. It's pulled back this way. That mean is not as resistant to this. The median is more resistant to these data points out here. So now let's go on and move to another thing that is descriptive in nature, is the mode of a data set. So sometimes it is classified as the measure of center. You always hear the mean, the median, and the mode as a measure of center. It can be, but it doesn't have to be. So I kind of stay away from that as a measure of center. So what is the mode? The mode of a data set is the value that appears most frequently in the data. If two or more values are tied for the most frequent, they are all considered to be modes. So you can have multiple modes in this case. If the values all have the same frequency, we say that data set has no mode. So all the values are basically the very same thing. There's no one point that adds more. So it would be a no mode. So let's look at this. Let's pull this data down. Put me down. Here's the data. With 10 students were asked how many siblings they had. The results, the range in order was 0, 1, 1, 1, 1, 2, 2, 3, 3, and 6. find the mode of this data set. So the mode here, I would go through and count the frequency of each one of these values. 0 is 1, only see it one time. 1, I see 4 times, the frequency is 4. 2, the frequency is 2. 3, the frequency is 2. And 6, the frequency is 1. So here clearly the 1s have the highest frequency by itself, so it's unimodal, one mode, and that mode value is 1. So the most common answer for the siblings is 1. Okay. You can also look at the mode from a bar chart, a frequency chart. The mode is sometimes classified as a measure of center. However, this isn't really accurate like I mentioned before. The mode can be the largest value in a data set or the smallest value. If it's really symmetrical or mostly symmetrical, that peak is going to be somewhere in the center, and that would be the mode. But this is certainly looks to be more left-tailed. So means and medians can be computed only for quantitative data. Remember, quantitative data were ones with numbers, 1, 2, 3, 4, measurable data, and we could do things with it. We could do math with it. The mode, we can't do it with qualitative. We can't calculate the mean and the median for qualitative data. Qualitative was descriptive type things. But if I sent out a questionnaire, did a poll, what's your favorite color, what's your favorite vehicle, and I listed it and I counted the frequency of the answers. So Ford might have been 576 out of the 1,000, Chevrolet 320 out of the 1,000. I could have the mode being the highest frequency. So I can do the qualitative data and have a mode for that. So following is a list of the makers of all the cars rented by an automobile rental company on a particular day. Which make of a car is the mode? We need to put it down, get this thing sorted, and start counting out which one's Ford, Honda. Let's see how many do I see? 2, 3 Hondas, and then I go through the Fords, and then I would count them all up, and then determine which one was the most popular, or which one was rented on a particular day, which one was most. So here Toyota appears most frequency, therefore the mode is Toyota. 1, 2, 3, 4, 5, 6, and that is the most popular, or most frequency. So that's the mode is Toyota. So here is we talked about doing the mean of just a data set where we added up individual data variables, the data points, divided it by the number of the data points that we had that we counted up. Here I want to approximate the mean using group data. So we're going to have to recall what group data is. Remember, the group data was if I built classes like values from 0 to 5, 5 to 10, 10 to 11 to 15. If I built those through classes, then I just counted the frequency in those classes and put them in those bins. That's group data. We can also refer to those as group data. So if I'm just given that bar chart, and here's the histogram, here's these classes, and here's the range that I'm talking about, if I would like to kind of do the mean from those, this is what I've got to do. I've got to basically use a midpoint of each class and then use the frequency to determine how many times that number has occurred. So let's see. Our step one is going to be compute the midpoint of each class. The midpoint of a class is found by taking the average of the lower class limit and the lower limit of the next larger class. So for each class, multiply the class midpoint by the class frequencies. I'm going to add up all of those products, the midpoint times the frequency, over all the classes, and then divide the sum obtained in this, step 3, by the sum of the frequencies. So here's what we're going to do. Let me pull this thing down here. Here's my table, my group data. These were number of messages sent. The following table represents the number of text messages sent by a cell phone by a sample of 50 high school students. approximate the mean number of messages sent, the average number of messages among all 50 using this grouping of data. Okay. So what I'm going to do, these frequency of 10 could be any numbers in here. Remember, we're just going through, if we had the original data, we would have everything. But now we've grouped all of these things into these bins, these classes. So I'm going to try to get a value of the mean from this group data. So what I'm going to do is say, put a representative number for the midpoint. So here, I'm going to take 0 and 50, divide by 2. So 50 plus 0 divided by 2 is 25. So this thing is going to be kind of centered around 25, and I could say to recover this, I've got 10 25s. So instead of being different numbers, I'm just going to use that 25 10 times. 50 plus 100 divided by 2, 150 divided by 2 is 75. That's that midpoint of this. And I see it 5 times, 75, 75, 75, 75. So I continue along with each one of these. And here's what I get. Here's my 25 from the first one. Here's the frequency of each one of these. But now I'm going to use these for all 4 frequencies, all 7, and then I can count up the mean. So instead of rewriting these things as 25 10 times, that's the same thing as 25 times 10. Plus I see 75 times 5, plus 125 times 13, plus 175 times 11, plus 225 times 7, plus 275 times 4. Add those up, finish doing that calculation, and then divide it by the 50 of the students that we were originally dealing with. So here's the value from each one of these, the midpoints times the 10, 25 times 10, that's obviously 250, and then continue on just multiplying these numbers. If we were in Excel, this would work really easy. I would just take these out, multiply these together, do my fill handle to calculate the rest of them, and then I could sum these up and divide it by the 50. So here's the midpoint times the frequency. Here's the ones that I'm adding up. Dividing it by the 50, I got 6850, and that'll give me 137 as the mean. And we will probably do this in lab using Excel. It's pretty quick. Okay. So here's at this point, remember we talked about how to compute and interpret the mean of a data set, either population or sample. We use mu for a population mean, x bar as the mean of a sample. The notation, those were those, x bar and mu. How to compute the median depends. If we've got even data, we order them. We always put them from least to the smallest to the greatest. If it's even, I find the middle two and average those two numbers. If it's odd, I find that middle number, and that is the median. We talked about TI-84 plus calculators. We'll do more of that in lab. And we'll also look at other calculators in Excel. The definition of resistant and which measure of center is resistant. Remember that was if I have an outlier or data that changes, how is it resistant to those changes? The median was very resistant. The mean is not. If you put in that winning the lottery, everything changed over for the mean. So how the mean and median are related to the shape of the data set, including skew to the left, the mean is left of the median. Skew to the right, your mean would be to the right of the median. And approximately symmetric, the two would align. The median is almost, it should be equal to or pretty close to it. You would think they were symmetric. How do I identify the mode of a data set? I just count up all the data members and see which one occurs most frequently. And then how to approximate the mean for group data. I do the midpoint, multiply it times its frequency. I do that for each class, the midpoint being the average between a lower and the next lower value for the class. Okay. I hope you found that informative. I hope it helps. We'll see you next time. Have a good day.